Welcome back. Joy Zeigler here. Let's get going with part 2 of lesson 10.5 through 7. We're on page 4 of the class notes. So the language you need to know is that any value for a variable that makes the inequality true is called a solution. The set of all solutions is called a solution set. Like equations, you can use the addition and multiplication properties to find a solution set. That means you can add the same number to both sides, or you can multiply both sides by the same thing, and you'll have equivalent inequalities. The graph of an inequality is placed on is a visual representation of the solution set, and they can be graphed on a number line. So let's look at an example. For x is less than or is greater than -5, it means that x can be any value that is larger than -5, or we would put greater than -5. But it would not equal -5 because it doesn't have that equal sign in it. So the solution set is written as an interval. This is hugely important. Here are some examples of intervals. Okay, here are 3 different examples that I've written. The bracket means it can include the 3 here. So the 3 is part of the solution set. Then everything in between 3 and 2 are included in the solution set, and the parentheses means that the 2 is not included in the solution set. Anytime you have infinity that you write as an interval, you are going to write a parentheses. So negative infinity would be on the left, it would have a parentheses. If positive infinity were here, it would have a parentheses, such as here. Then on the right we have 4 with a parentheses, so that means that 4 itself is not included in the solution set, but everything between negative infinity and 4 is included, which is basically you're just saying everything less than 4. In the third interval, it's everything in between 5 and 8, does not include 5, does include 8. So in the statement x is greater than -5, the interval is written, x can start with but not include -5, and here's a number line showing -5. So we actually place that parentheses instead of a bracket on the -5 to show that the interval does not include -5, but it starts there. So we put in a parentheses here. And then we shade in everything from -5 all the way to the right, and it keeps going forever, and so we indicate that with an infinity sign. So the interval, I like plotting the inequality first so that you can see it visually, and then when you write the interval, you look at the inequality and you say, what's on the left? There's a parentheses. I'm going to draw a parentheses. Where's the parentheses at? It's at -5. Okay, comma. What's on the right? Infinity's on the right, so I'm going to draw an infinity, and I know the rule that every time you have infinity, you have a parentheses. So I've written my interval in interval form, and it's the same as what they're saying up here. So when we're talking about interval notation, we are using the following concept. A parenthesis indicates that the end point is not included in the solution set. A bracket indicates that the end point is included. Let me get that. A parentheses is always used next to an infinity symbol, either negative infinity or positive infinity. And if you are answering in interval form, that the set of all real numbers, what the set of all real numbers is, you would write it this way: parentheses, negative infinity, comma, infinity, end parentheses. So the set of all real numbers is written in interval form or interval notation as negative infinity to positive infinity with parentheses on both sides. So you never use brackets with infinities. Okay, in this case we're graphing 3 is greater than x. So notice that x is on the right side. When we're dealing with inequalities, we want x to be on the left side. So in order to move x to the left side, we need our arrow to keep pointing at x. So that means we reverse the direction of our inequality. So 3 is greater than x is the same thing as x is less than 3. And like I said, I like to graph that first. We come and find 3 on the number line, which is right here. Then we look at our inequality symbol, and it's less than. It is not less than or equal to. So for that reason, we use a parentheses. I'm going to redraw it. At 3, and then since x is less than, that means it moves off to the left. It can include anything to the left of 3 all the way to negative forever, which we call negative infinity. And so, and as you can see, I've marked over it, but you have a negative infinity here. So when you write your intervals, you come and you look, what is leftmost on my number line? Well, leftmost is negative infinity, and negative infinity always has a parentheses. Rightmost is 3, and I see a parentheses on my number line, so that is going to be my interval that goes right here. Okay, here we have a 3-part inequality. Negative 3 is less than or equal to x is less than 2. And the interval notation would be that negative 3 is on the left with a bracket because it's less than or equal to. So negative 3 is on the left, 2 is on the right, and x is in between. So like I said, this is why I like to draw it better. If I was going from this statement, I would come down to my number line and find negative 3, and I would put a bracket because of the less than or equal to symbol. And then I would say that's less than x, so x is going to the right all the way to 2. So I would look for 2 on my number line, and since I have a less than instead of a less than or equal to, I would use the parentheses. And then I would shade everything in between. Now when I write my interval form of the solution, I would look on the left and I see a bracket. Then I see the negative 3. I know a comma goes next. I look on the right, I see a 2, and I see a parentheses. So that's why I like to do the number line and get a visual representation first before writing the interval, and that is the interval. So this means that any number between negative 3 and 2, including negative 3 but not 2, is a solution. Are negative 3 and 2 solutions? Well, negative 3 is, but 2 is not, because of this less than sign that does not have an equal component. We use parentheses to symbolize less than or greater than signs, and brackets to symbolize less than or equal to or greater than or equal to signs. Okay, you're not going to be tested on this set builder chart, but it is interesting to look at a few things. The intervals are presented in set builder notation in this way, and you will need to know how to do this. So the way this reads is you have bracket, you have x is such that a is less than x is less than b. So that's how you would write in set builder notation if you have an interval. So for instance, if you have the interval 4, 3, you would write that as x such that 4 is less than x is less than 3. Okay, so that's all I'm going to really say about set builder notation. And then the graph of that interval is as we did before. It looks like this. Now this is when you have a three-part interval. You're going to have endpoints, either parentheses or brackets, but you're going to have endpoints, no infinities. So if you have like 4 is less than x is less than 3, which you would never have, you'd have 4 is less than x is less than 5. So let me correct that. The reason that was incorrect is because this number here is never less than 3. 4 is never less than 3, because on a number line 4 is never to the left of 3. So this number here has to always be bigger than this number here. Okay, an open interval is shown where you have parentheses on both sides. A closed interval has brackets on both sides. You don't need to know that. A disjoint interval you will need to know. A disjoint interval has a graph over this way, a graph over this way, and area in between that is not included in the solution set. And it's shown like this. It's shown that everything from negative infinity to a is included in the solution, and everything from b to positive infinity is included, and they are united. So this symbol is called a union symbol. And so we will put this to work. Right now I'm just exposing you to the idea. Okay, if you just have x is greater than a, your graph's going to look like this, where something goes off to infinity. And if you have x is all real numbers, that would be a graph from negative infinity to positive infinity. Okay, reminder that the addition property works for inequalities. You can have two inequalities which are equivalent if they have the same solution set. And if you have an inequality and you add the same thing to both sides, you have an equivalent inequality. That's all C is saying. So let's look at example 4. We want to solve for k. So we're going to use the same tools we used for equations, only we're going to use them for inequalities. We want the k terms on one side of the equation. So first of all, let's subtract 2k from everything. And on the left, we get 7 plus k is greater than or equal to negative 5. Okay, and let's move over here. So now we want k by itself. We need to get rid of that 7, so we're going to subtract 7 from both sides, and we are left with k is greater than or equal to negative 12. So there we have our inequality. We have k is greater than or equal to something, so we've simplified it as far as we can. Now let's draw that on a number line. Let's find number 12, and we have this equal component, so we know we're going to be using brackets. So let's find negative 12, and it's over here. So we put a bracket there, and k is greater than that as well as equal to that, so k goes off to the right till infinity. And that's our graph. That's our solution set in graph form. Now let's give it an interval form, and we do that by looking at the graph and saying we have a bracket on the left, then we have negative 12, comma, we have an infinity on the right, parentheses always goes with infinity. And there, voila, we have solved our interval form. Okay, to test whether your solution is right or not, then you can't test all of the points because you have an infinite number of points. But you can choose a point inside of your solution area and the inequality should be true when you plug it in. Choose a point outside, it should be false, and then choose a boundary point to see if that works for the boundary equation. So for example, I'm going to do these in red. Let's choose a boundary point. There is one boundary point, and that is -12. So when k equals -12, we have -12 is greater than or equal to -12. Well, -12 isn't greater than, but it is equal to, so that's fine. Then we choose a point outside our solution area. Let's choose -13, and we have, if we plug in -13 for k, we have -13 is greater than or equal to -12. But we know that's not true because on the number line, -13 is to the left of -12, so that's false. Well, since we chose -13 outside of our solution set, we would expect it to be false. So that's a good answer. Let's choose a number inside our solution set. Let's choose 0. If we plug in 0 for k, is 0 greater than or equal to -12? And yes, 0 is greater than or equal to -12, so that's true. So we just solved and verified our solution. So now let's come down here to D and look at the multiplication principle. And basically it says you can multiply by the same thing on both sides of the inequality and you will have an equivalent inequality. So A is less than B is equivalent to AC is less than BC, and the same is true for greater than. At this point, go on to part 3 of this lesson.